Hello everyone, this is Abhishek and today we are going to discuss about introduction to DBMS. Database are the backbones of modern computing and powering everything from social media platform to financial experts. At the heart of these databases is the database management system, a powerful software that allows us to create, manage, and interact with databases efficiently. In this introduction, we will explore the fundamentals of DBMS, its key components, and critical role it plays in the world of information technology. What is database management system? Definition. Database management system is a software application designed to manage and control the creation, storage, and manipulation of data within the database. It serves as an intermediary between the user and the database, providing a structured and efficient way to interact with the data. Key functions. The primary function of database management system include data storage, data retrieval, data security, data integrity, and data concurrency control. It also provides tools for database administration, query optimization, and performance tuning, ensuring the database operation efficiently. Benefits. By using DBMS, organizations can centralize and standardize their data, reduce data redundancy, improve data integrity, and enhance data security. This in turn leads to better decision making, increased productivity, and more efficient resource utilization. Components of database management system. Database. The database is the core component of DBMS, where all the data is stored in a structured and organized manner. It provides a centralized reprocessing for information, allowing for efficient data management and retrieval. User interface. The user interface is the means of by which the user interact with DBMS, allowing them to create, read, update, and delete data. This can be in the form of graphical user interface, GUI, command line interface, or application program interface API. Query engine. The query engine is responsible for programming and processing and executing user queries, converting them into efficient database operation. It ensures that the data is retrieved, manipulated, and stored in accordance with the user request. Storage management. The storage management component of a DBMS is responsible for physical storage and retrieval of data, managing the underlying files, system, and storage device to ensure the optimal performance and data integrity. The database models, relation model. The relation model is the most widely used database model where data is organized into tables with rows representing individual records and columns representing different attributes. This model emphasizes the relations between data, allowing for efficient query and data manipulation. Hierarchical model. In the hierarchical model, data is organized in the tree-like structure with the root node and child node. This model is well suited for representing data with a clear parent-child relation, such as an organization, charts, or file systems. Network model. The network model is similar to the hierarchical model, but it allows for more complex relations between data, with each record potential having multiple parents. This model is more flexible but can also be complex to manage and maintain. Data definition language, DDL. The create statement is used to define a new database organized system such as tables, views, and index. It allows you to specify the structure and properties of objects, including column name, data types, and constraints. Alter. The alter statement is used to modify the structure of an existing database object. It can be an object. It can be used to add, drop, or modify columns, constraints, and other properties of the table or view. Drop. The drop statement is used to remove an existing database database object such as table, view, or index. This is powerful command that should be used with a caution as it can cause a lead to the permanent loss of data if not handled properly. Data manipulation language, DML. The select statement is used to retrieve data from another more table. It allows you to specify the columns you want to retrieve as well as filtering or sorting setting. Insert. The insert statement is used to add new data or table. It allows you to specify the values of each column in a new row or to insert data to another table. Update. The update statement is used to modify existing data in table. It allows you to change the values of one or more columns for a set of rows that met the specified condition. The delete statement is used to remove data from a table. It allows you to specify the row you want to delete based on the set of condition. Database normalization. First normal form, the 1F. The first normal form ensures that each table has the primary key and that all data is stored in a tabular format with no repeated groups or nested data. Second normal form, 2NF. The second normal form requires that all non-key attributes are fully dependent on a primary key. This helps to eliminate partial dependency and reduce data redundancy. Third normal form, 3NF. The third normal form ensures that all non-key attributes are independent for each other and do not depend on anything other than the primary key. This helps to eliminate transitive dependency and further reduce data redundancy. Transaction and concurrency control. Locking. Locking is a mechanism used to ensure data integrity by preventing multiple users from modifying the same uh, data at the same time. It allows only one user to access particular resource at a given time. Time snapping. Time snapping is a technique used to manage the order of transaction, ensuring that they are executed in a way that maintains data consistency and integrity. It assigns a unique time test for each transaction, which is used to resolve conflicts. Rollback. Rollback is a mechanism that allows a transaction to be undone, restoring a database to its state before the transaction was executed. This is useful when the transaction fails or needs to be cancelled for any reason. Database security and backup. Authentication. Authentication is a process of verifying the data of a user or an application before granting them access to a database. This can be done through password, biometric, or other security measures. Authorization. Authorization is a process of determining what actions a user or an application is allowed to perform within the database. That can be done through the use of roles, permissions, and access control lists. Encryption. Encryption is a process of converting data into coded format that can be only accessed by authorized users. This helps to protect sensitive information from unauthorized access or theft. Backup and recovery. Regular backups or database are essential to protect against data losses due to hardware failures, human error, or other unexpected events. Backup and recovery strategies help to ensure that the data can be restored in the event of a disaster. Distributed database scalability. Distributed database can scale more easily by adding more services to the network, allowing them to handle large amounts of data and more concurrent users. Availability. If one user fails, the data can be still accessed from the server, increasing the overall availability of the database system performance. Distributing data and performing access multiple servers can improve queries responses times as the load is shared among the different nodes. Fault tolerance. Distributed databases are more resilient to failures as the loss of single server does not result in entire system going down. Thank you.